All right, here in example 2, we're going to once again look at applying the centroid theorem. So in this one, they give us triangle LMN. They tell us the length of PY right here is 7. We know that's going to be 1/3 of this whole length, right? 2/3 of this length is over here, 1/3 is here. So if 1/3 is 7, then 2/3 would have to be 14. I think that's what they want us to figure out. Right? They wanted us to figure out LP. So they're going to show a bunch of steps that you could do that algebraically. For me, I just kind of I'm looking at this and I'm saying, okay, 1/3 of it is PY, 2/3 of it is PL. So whatever this length is, this one is just twice as big, right? That should be true. Whatever length ZP is, MP is twice as big. Whatever length XP is, NP is twice as big. Right? That is what our centroid theorem tells us. That when you make those medians and you have them cross over at a centroid, that centroid cuts them into two pieces where one of those pieces is twice as big as the other. Okay, here it says because LX is congruent to XM, so these two lines marked with the 1 on each of them, then that means X is the midpoint of LM, okay, and NX is the median of LMN. Okay, they're just saying that we know these are medians in the picture because of these congruency symbols. Okay, if we can say that this and this are the same size, that makes that the midpoint. These two are the same size, therefore that must be the midpoint. These two are the same size as each other, therefore that's the midpoint. That's all they're getting in here. Likewise, Y and Z are the midpoints of the other ones, yada, yada, yada. Okay, so the way that they write this out is they say that they start with the centroid theorem without any information like PY being in there yet. They say that LP is 2/3 of LY, right? This bigger piece is 2/3 of the whole thing. LY is LP and PY together, so LP and PY together. So they kind of substitute that in. And then what they do is they say that we know PY. PY was given to us. It was 7. So we have 2/3 multiplied by LP, which shows up here, and 2/3 multiplied by 7. So 2 and 7 make 14, so we get 14/3. This was just using the distributive property. Once you've got that, we can subtract 2/3 LP from each side. We're just trying to get our unknowns only in one spot, so we get rid of them on one side. So evidently we got rid of them on the right side by subtracting 2/3 LP on both. Well, if you had a full LP before and you take away 2/3 of it, you're just left with 1/3 of LP. At this stage, if we multiply both sides by 3, it tells us that LP is 14. Now that's obviously, in my estimation, a much longer way to do this than is necessary. For me, I would just say that this piece is going to be twice as big as that one, and they told me how big that one was. Let's try it over here. In triangle XYZ, SP is 3.5. Find PZ. Well, once again, we could go through all those steps that they showed, and it's not bad to have the skill to do that. But just in general, kind of getting the conceptual understanding, the short piece is going to be half as big as the big one. So PZ is going to be 7. And that's really all there is to it on this one. Cool.